Example 9. Using the same function, evaluate f of t raised to the third power. Note that in this example, the same variable is used in the input expression and as the input variable of the function. This doesn't matter. We still replace the original input t in the formula with the new input expression t to the third. F of t to the third equals t to the third squared minus t to the third equals t to the sixth minus t to the third. This now allows us to find an expression for a composition of functions. If we want to find a formula for f of g of x, we can start by writing out the formula for g of x. We can then evaluate the function f of x at that expression as in the examples above. Example 10. Let f of x equals x squared and g of x equal 1 over x minus 2x. Find f of g of x and g of f of x. To find f of g of x, we start by evaluating the inside, writing out the formula for g of x. G of x equals 1 over x minus 2x. We then use the expression 1 over x minus 2x as input for the function f. F of g of x equals f of 1 over x minus 2x. We then evaluate the function f of x using the formula for g of x as the input. Since f of x equals x squared, f of 1 over x minus 2x equals 1 over x minus 2x squared. This gives us the formula for the composition. F of g of x equals 1 over x minus 2x squared. Likewise, to find g of f of x, we evaluate the inside, writing out the formula for f of x. G of f of x equals g of x squared. Now, we evaluate the function g of x using x squared as the input. G of f of x equals 1 over x squared minus 2x squared. Example 11. A city manager determines that the tax revenue, R, in millions of dollars collected on a population of P thousand people is given by the formula R of P equals 0.03p plus square root of P, and that the city's population in thousands is predicted to follow the formula P of t equals 60 plus 2t plus 0.3t squared, where t is measured in years after 2010. Find a formula for the tax revenue as a function of the year. Since we want tax revenue as a function of the year, we want year to be our initial input and revenue to be our final output. To find revenue, we will first have to predict the city population and then use that result as the input to the tax function. So we need to find R of P of t. Evaluating this, R of P of t equals R of 60 plus 2t plus 0.3t to the squared equals 0.03 multiplied by 60 plus 2t plus 0.3t squared plus the square root of 60 plus 2t plus 0.3t to the squared. This composition gives us a single formula which can be used to predict the tax revenue during a given year without needing to find the intermediary population value. For example, to predict the tax revenue in 2017 when t equals 7, because t is measured in years after 2010, r of p of 7 equals 0.03 multiplied by 60 plus 2 times 7 plus 0.37 squared plus the square root of 60 plus 2 times 7 plus 0.37 squared is approximately $12.079 million. Domain of compositions. When we think about the domain of a composition, h of x equals f of g of x, we must consider both the domain of the inner function and the domain of the composition itself. While it is tempting to only look at the resulting composite function, if the inner function were undefined at a value of x, the composition would not be possible. Example 12. Let f of x equal 1 over x squared minus 1 and g of x equals square root of x minus 2. Find the domain of f of g of x. Since we want to avoid the square root of negative numbers, the domain of g of x is the set of values where x minus 2 is greater than or equal to 0. The domain is x is greater than or equal to 2. The composition is f of g of x equals 1 over the square root of x minus 2 squared minus 1 equals 1 over x minus 2 minus 1 equals 1 over x minus 3. The composition is undefined when x equals 3, so that value must also be excluded from the domain. Notice that the composition doesn't involve a square root, but we still have to consider the domain limitation from the inside function. Combining the two restrictions, the domain is all values of x greater than or equal to 2 except x equals 3. In inequalities, the domain is 2 less than or equal to x and x less than 3 or x greater than 3. In interval notation, the domain is close parentheses, 2, 3, open parentheses, union, open parentheses, 3, infinity, open parentheses. Decomposing functions. In some cases, it is desirable to decompose a function, to write it as a composition of two simpler functions. Example 13. Write f of x equals 3 plus the square root of 5 minus x squared as the composition of two functions. We are looking for two functions, g and h, so f of x equals g of h of x. To do this, we look for a function inside a function in the formula for f of x. As one possibility, we might notice that 5 minus x squared is the inside of the square root. We could then decompose the function as h of x equals 5 minus x squared. G of x equals 3 plus square root of x. We can check our answers by recomposing the functions. G of h of x equals g of 5 minus x squared equals 3 plus the square root of 5 minus x squared. Note that this is not the only solution to the problem. Another non-trivial decomposition would be h of x equals x squared and g of x equals 3 plus 5 minus x.